Hello dear students, I am Ramesh Narayan Tripathi and my physics channel is Physics R&T. We are going to solve some multiple choice questions on Newton's law of gravitation. At first, let us review the basic formulas and helping tips. First formula, gravitational force of attraction between two objects of masses m1 and m2 separated by distance r is given by F is equal to G m1 m2 upon r square, where capital G is gravitational constant having its value as 6.67 into 10 to minus 11 Newton meter square upon kg square. On Earth's surface, acceleration due to gravity small g is equal to gm upon r square, where m is the mass of Earth and r is the radius of Earth. Correct form of gravitational law is F vector is equal to minus g m1 m2 r vector upon r cube. Here negative sign indicates the force of attraction between two objects. Next, gravitational force is conservative and exists everywhere. Next, atmosphere is held to the earth by gravity. Next, region of weightlessness in satellite is zero, reaction force by satellite surface. Next, gravitational constant capital G is independent of the nature of medium between two objects. Next, gravitational field inside a closed shell or surface is zero. Now, we take first question. Two identical solid copper spheres of radius r are placed in contact with each other. The gravitational force of attraction between them is proportional to, these are the options. Now, solution to question 1. Suppose these are two identical copper spheres, each of radius capital R. So, its radius is capital R and also its radius is capital R. Total separation between two masses will be 2r. Now, gravitational force of attraction between two spheres will be G m upon distance square, distance is 2r square. If rho is the density of copper, then it can be written as G m square upon 4 r square, which can be rewritten as G upon 4 r square into mass is equal to volume into density. So, volume of a sphere is 4 by 3 pi r cube into density whole square. It is G upon 4 r square into 16 upon 9 pi square rho square r power 6. So, it is 4 by 9 pi square rho square G r power 4. This term is constant. So, it is constant times r power 4. So, F is directly proportional to r power 4 and the correct option will be C. Next, question number 2. The question is, the gravitational force F between two objects does not depend on, these are the options. As we know, gravitational force of attraction between two objects is directly proportional to the product of two masses and inversely proportional to square of distance between them. So, it does not depend upon the sum of two masses, and correct option will be B. Next question number 3. The question is, two astronauts are floating in gravitational free space after having lost contact with their spaceship. The two will, these are the options. Clearly, when the astronauts are moving in free space, getting lost from their spaceship, then both will move towards each other due to gravitational attraction between them. So, the correct option will be D. Next question number 4. The question is, a satellite of Earth is revolving in circular orbit with uniform velocity v. If the gravitational force suddenly disappears, then the satellite will. These are the options. So, solution to question 4. Suppose this is satellite moving in circular orbit around Earth. When the gravitational force disappears, then the satellite will be moving towards the tangent with same velocity. So, the correct option will be C. Move with velocity v tangentially to the orbit. Next question number 5. The question is, two particles of equal mass go round a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle is. So, solution to question 5. Here, suppose this is one particle and this is another particle. Radius of circle is r. So, diameter will be 2r. The mass of each particle is m. Both are moving with velocity v. So, the gravitational force of attraction between these two particles will provide necessary centripetal force. So, centripetal force mv square will be mv square upon r will be equal to g m upon distance square means 2r square. So, 1 m cancels out and we get v as g m upon 4 r square into r under root. So, it becomes 1 upon 2 under root g m upon r. So, the correct option will be C, 1 upon 2 g m upon r. Next question number 6. The question is, a point mass m is placed inside a spherical shell of mass capital M and radius capital R at a distance r by 2 from the center of shell. The gravitational force on the point mass by the shell will be, these are the options. As we know, the gravitational field inside a spherical shell is 0. Therefore, the gravitational force will be also 0 and the correct option will be D. Next question number 7. The question is, two point masses A and B having masses in the ratio 4:3 are separated by a distance 1 meter. When another point mass C of mass capital M is placed between A and B, the force between A and C is 1/3 of the force between B and C. Then the distance of C from A will be, these are the options. Now, solution to question 7. Suppose this is point mass A and point mass B. Its mass is m1 and its mass is m2. another point mass C is placed between them. Suppose R1 is the distance from A to C and R2 is the distance from B to C. Total distance between A and B is 1 meter. Here M1 upon M2 is given to be 4/3 and force between A and C means, suppose this is force F1 and this is force F2. F1 is 1/3 F2. So F1 will be the gravitational force between A and C, between M1 and capital M. G M1 capital M upon R1 square will be equal to G M2 capital M upon R2 square into this 1/3. So F1 is equal to 1/3 F2 according to question. Hence G M1 M upon R1 square will be equal to 1/3 G M2 M upon R2 square. Capital G and capital M get cancelled. So we get M1 upon M2 is equal to 1/3 R1 upon R2 whole square, and M1 upon M2 is given to be 4/3. So we get R1 upon R2 square as 3 cancels, it is 4, which gives R1 upon R2 is equal to root of 4 means 2. This means that R2 will be equal to 1/2 R1, that is 0.5 R1, but R1 plus R2 is equal to 1 meter. Hence R1 plus 1/2 R1 is 1 meter, 3/2 R1 is 1 meter. So R1 will be equal to 2/3 meters. So the correct option will be B, 2/3 meters. Next question number 8. The question is, 3 equal masses of 1 kg each are placed at the vertices of an equilateral triangle PQR, and a mass of 2 kg is placed at the centroid O of the triangle, which is at distance root 2 meter from P, Q and R each. Net force in Newton on 2 kg mass is, these are the options. Now solution. Suppose this is equilateral triangle PQR. At the vertices PQR each 1 kg mass are placed, and at the centroid O 2 kg mass is placed. Also PO is equal to RO is equal to QO is given to be root 2 meter. Suppose this is R. Now clearly the magnitude of all these 3 gravitational forces F1, F2 and F3 will be same, equal to G small m capital M upon R square. Here G small m capital M upon R square, G small m capital M upon R square, G small m capital M upon R square. So it is equal to G small m is 1, capital M is 2 upon root 2 square, which gives G. So the magnitude of F1, F2 and F3 is equal to gravitational constant G. Now, if we resolve F2 in horizontal and vertical component, we get F2 cos 30 because this angle is 120, total angle is 180, total angle is 180. So, this angle and this angle will be equal to 30 degree each. So, horizontal component of F2 will be F2 cos 30 and vertical component F2 sin 30. Similarly, horizontal component of F3 will be equal to F3 cos 30 and vertical component will be F2 sin 30 as shown in the diagram. Now, the resultant vertical force on 2 kg mass will be equal to F1 minus F2 sin 30 plus F3 sin 30. So, it gives F1 is G, F2 is G and sin 30 is 1 by 2, F3 is also G and sin 30 is G by sin 30 is 1 by 2. So, vertical component will be 0. Similarly, the resultant horizontal force on 2 kg mass will be F2 cos 30 minus F3 cos 30, which is again 0. So, the resultant force on mass 2 kg at centroid O will be 0. So, the correct option will be D.